group members:
Dexter Nardo, Mela Albader, Danica Quiambao, Erica Sabato, Christian Villegas, Ezekiel Catacuden, John Benjamin Racina, Lean Dela Cruz, and Gerwin Mejia. The Critical Path Method.
The Critical Path Method, or CPM, is a strategy for identifying activities required for project completion and determining schedule flexibility. In project management, a critical route is the longest series of operations that must be completed on time for the project to be completed. Any delays in important activities will cause the remainder of the project to be delayed. CPM was created in the late 1950s to address the issue of higher expenses caused by poor scheduling. CPM has since gained popularity for project planning and work prioritization. It enables you to divide large projects into smaller jobs and acquire a better grasp of the project's flexibility.
Significance of Critical Path Method.
Critical Path Method may help you plan projects, allocate resources, and schedule activities more effectively.
These are some of the benefits of using this method.
1. CPM may be used to compare expectations with actual progress, which improves future planning. Current project data can be utilized to guide future project plans. 2. Improves resource management. CPM assists project managers in prioritizing tasks, providing them a better notion of how and where to deploy resources. 3. Avoids bottlenecks. Inefficiencies in projects can result in wasted time. Using a network diagram to plot out project dependencies can give you a better picture of which tasks can and cannot occur in parallel, allowing you to schedule properly.
How to do Critical Path Method.
In this video, we will discuss how to do the Critical Path Method. We will be needing the list of activities, predecessor, and duration of the activities in weeks. Let us have an example. XYZ Innovatech Co., Ltd. wants to calculate a project with 10 given activities. These activities are labeled A to J. Each activity has its given predecessor, which means dependent of the preceding activity. Lastly, each activity has a given duration. In Critical Path Method, we will construct a project network, determine its forward and backward passes, computation of slack, and find the critical path.
Construction Project Network.
First, in constructing a project network, we will be using diagrams like this. A represents the activity described. T represents the expected duration, or time of the activity. ES represents the earliest start of the activity. EF represents the earliest finish of the activity. LS represents the latest start of the activity. LF represents the latest finish of the activity.
We will now proceed in making the project network. First, let us arrange the activities using nodes.
Activities A, B, and C have no predecessors, so they can begin at start. Activity A needs to be completed before activity D starts. Activity B needs to be completed before activity E starts. Activity C needs completed before activity F and G starts. Activities E and F needs to be completed before activity H starts. Activity D needs to be completed before activity I starts. Activities G and H needs to be completed before activity J starts. Activities I and J will go to finish. Now that we have the nodes completed, we just use the diagram, so we can now proceed to the next step.
Forward passes.
We will now proceed in making the forward passes of the project. In this part we will identify the earliest start and the earliest finish of each activity. These are the steps in making the forward passes in this project. Activities A, B, and C have no predecessors, so the earliest starts of these activities are 0. Activity A needs 6 weeks to be completed, so the earliest finish of activity A is 6. Activity B needs 3 weeks to be completed, so the earliest finish of activity B is 3. Activity C needs 4 weeks to be completed, so the earliest finish of activity C is 4. 5. Activity A is the predecessor of activity D, so the earliest start of activity D is 6. Then, activity D needs 2 weeks to be completed, so the earliest finish of activity D is 8. We must add the earliest start and the duration of the activity for the forward pass. Activity B is the predecessor of activity E, so the earliest start of activity E is 3. Then, activity E needs 3 weeks to be completed, so the earliest finish of activity E is 6. Activity C is the predecessor of activity F, so the earliest start of activity F is 4. Then, activity F needs 5 weeks to be completed, so the earliest finish of activity F is 9. Activity C is also the predecessor of activity G, so the earliest start of activity G is 4. Then, activity G needs 3 weeks to be completed, so the earliest finish of activity G is 7. Activities E and F are the predecessors of activity H, so the earliest start of activity H is 9 because we must write higher earliest finish between activities E and F. Then, activity H needs 5 weeks to be completed, so the earliest finish of activity H is 14. Activity D is the predecessor of activity I, so the earliest start of activity I is 8. Then, activity I needs 5 weeks to be completed, so the earliest finish of activity I is 13. Activities G and H are the predecessors of activity J, so the earliest start of activity J is 14. Then, activity J needs 3 weeks to be completed, so the earliest finish of activity J is 17. Therefore, we complete the forward passes with a project completion time of 17 weeks.
Backward passes.
We will now proceed to the backward passes, which is basically the opposite of forward passes. This determines the latest start and latest finish of each activity. These are steps in doing backward passes for this project. We will start at the finish where the project completion time is 17 weeks. Activity J is the predecessor of the finish, so the latest finish of activity J is 17. Then, activity J needs 3 weeks to be completed, so the latest start is 14. To get the latest start, the latest finish should be subtracted to the duration of the activity. Activity I is the predecessor of finish, so the latest finish of activity I is 17. Then, activity I needs 5 weeks to be completed, so the latest start is 12. Activity H is the predecessor of activity J, so the latest finish of activity H is 14. Then, activity H needs 5 weeks to be completed, so the latest start is 9. Activity G is the predecessor of activity J, so the latest finish of activity H is 14. Then, activity G needs 3 weeks to be completed, so the latest start is 11. Activity F is the predecessor of activity H, so the latest finish of activity F is 9. Then, activity F needs 5 weeks to be completed, so the latest start is 4. Activity E is the predecessor of activity H, so the latest finish of activity E is 9. Then, activity E needs 3 weeks to be completed, so the latest start is 6. Activity D is the predecessor of activity I, so the latest finish of activity D is 12. Then, activity D needs 2 weeks to be completed, so the latest start is 10. Activity C is the predecessor of activities F and G, so the latest finish of activity C is 4, because we have to get the lesser latest start between activities F and G. Then, activity C needs 4 weeks to be completed, so the latest start of activity C is 0. Activity B is the predecessor of activity E, so the latest finish of activity B is 6. Then, activity C needs 3 weeks to be completed, so the latest start is 3. Activity A is the predecessor of activity D, so the latest finish of activity D is 10. Then, activity A needs 6 weeks to be completed, so the latest start is 4.
We now completed the backward passes for each activity. Now we will determine the slack values. Slack values.
The slack for an activity is defined as how long the activity can be delayed without extending or increasing the project completion time. It is calculated as LSES or LFEF. Therefore, the slack values of each activity are the following. The slack value of activity A is 4. The slack value of activity B is 3. The slack value of activity C is 0. The slack value of activity D is 4. The slack value of activity E is 3. The slack value of activity F is 0. The slack value of activity G is 7. The slack value of activity H is 0. The slack value of activity I is 4. The slack value of activity J is 0.
Determining the critical path.
The critical path of the project are activities with 0 slack value that must commence with the time in either earliest start and latest start, or must be completed with the time and earliest finish and latest finish. Simply, it means these are activities in the project that must be completed without any delay. In this project, it means activities C, F, H, and J are the critical paths.
That's all. I hope you learn a lot in our discussion about critical path method. Thanks for watching.
Let's start.